Now let us see what is macro and procedure. Now let us take a simple program which will add two numbers, add two given numbers. Okay. We will use macro and procedure in this program. First let us fix the data segment of the program. First data is I need two numbers, so I'll be inputting two numbers via keyboard. So I should get a prompt, a message 1, db defined by give first number. Then you have to put a dollar symbol because this dollar indicates the end of the string in assembly language of 8086. Then prompt for the second number, message 2, and message 3. Sum equal to dollar. Okay, this is my data ends. And I am using arrays to store the result. My code assume cs colon code base colon my data cs colon my code then the label start move a comma my data move ds comma x. Then I should get a prompt for entering the first number. Okay, so to display the string, the function h,09h, that is the dose function number which will display a given string. The input requirement is move dx comma offset of msg1, that is the dx should contain the offset of the message or string to be displayed. Output requirements is not specified. Then int21h, it will display the first message. Okay, let us check whether will this work or not. Terminating the program, move age comma dose function number for say h. Then input requirement is the return code move el comma 00h. Then int to 1h. Those input called. That is the end of my code. In start. Okay, let us save this program. Means add to num. Let us try to execute this. Okay, I not know assume is there. Okay, no error. Okay. Let us run it. Add to num.exe. Okay, give first number. So this works fine. So I can think about displaying the next message. So I have to copy this, paste it here, and change it to message2. For third message, again I have to copy paste the same lines. Now I am repeating these three statements again and again for every message. So I can make this the repeated set of statements as a macro for a procedure. Let us try the macro first. Okay, so instead of repeating all these statements, I am creating a macro print message macro, then in general a variable, msg is the variable. Then I will be writing the statements move h, 09h, move dx, offset of the message to be displayed. Here it is msg, then int to 1h. Writing these three statements inside this macro, and this is the end of the macro. Okay, now I have created the macro. Then instead of this, I can call the macro. My macro name is printmsg. So I'll be writing printmsg, my macro name. But I want to print the first message, that is msg1, and msg2, two messages. Okay, let us try will this work or not. So again translate it. Legal instruction, what is it? Print, okay, print MSG. Okay, then linking, then running it. Okay, give first number, give second number. Both messages are printed. Next, how to read a number. So let me try a message, try a procedure. Okay. For printing a message, we use a macro. For reading a number, we are using a procedure. Okay. Well, let us try a procedure. So, what is the method to read a two-digit number? I have a DOS function, that is I have a DOS interrupt function 01h to read a character from keyboard with echo. That is, keyboard is the key first is displayed on the screen. Okay, its input requirement is AH equal to 01h, and output specification is AL. After pressing the character, its ASCII code will reach the AL register character. That is, suppose I want to read the number 25. So first I will press 2. Press 2. What will be the content of AL? AL equal to ASCII of 2. What is ASCII of 2? It is 32H. AL will be 32H. If I press 2, AL will be 32H. See, 30 is the ASCII of 0, 31 is the ASCII of in hexadecimal, 31H is the ASCII of 1, 32H is the ASCII of 2, then 39H is the ASCII of digit 9. Okay, then how can I achieve 2 from 3 to H? So I should get the digit. Okay, but forming a 2-digit number means of 25. First I will pressing 2, and 2 into 10 plus 5, it is 25. So but I got 3 to H, not the digit 2. So to extract the digit 2, I will be subtracting 30H from 3 to H. I will be getting 2. Okay, the digit 2. Now I can multiply it with 10. I will be getting 20. Then I will press the next character 5. I will be getting 3 5 in AL. Again I will be subtracting 3 zeros. I got the next digit at the unit position 5. Then I will be adding previous 20 plus this 5. I will be getting 25. That is the method. In 8086 we have 8-bit multiplication and 8-bit division, 16-bit multiplication and 16-bit division. See the 8-bit multiplication. An example is mul BL. That is, along with the instruction we will specify an 8-bit register. what is happening is AX equal to AL into the 8-bit register specified in the instruction. So mul BL means AX equal to AL into BL. The result is stored in AX register. Then in 16-bit multiplication, example is mul BX, that is mul a 16-bit register. The result will be stored in result will be a 32-bit value, so it will be stored in two 16-bit registers DX and AX, and the value will be AX into the content of 16-bit register specified along with the instruction. See the 8-bit division. Example is div BL, div an 8-bit register. It will divide the AX register, the content of AX register with the content of the 8-bit register specified along with the instruction. Your quotient will be stored in AL and your remainder will be stored in AH. Then 16-bit division, example is div BX. We will specify a 16-bit register along with the instruction. The 30-bit value stored in DX and AX will be divided by the content of the 16-bit register, and your quotient is stored in AX register and remainder is stored in DX register. Now we know how does this mul instruction works. Next, let us start write the procedure. We are designing a near procedure. There are two types of procedures, for procedure and near procedure. Near procedure is one which resides in the same code segment. So I will write it after the instructions to terminate the program. Our procedure name is read num. Proc is an assembler directive. Near is another assembler directive. Now read num is a near procedure. NP is another assembler directive which indicate the end of the procedure. So in our procedure we use the DOS interrupt 21 function 01h, which will read a character from the keyboard with echo. So move h, 01h INP to 1h. We are planning to read 25. Now we will be pressing the character digit at the 10th position. When we press 2, the ASCII of that character pressed in AL register. So we want to make it the digit. So sub AL, 30H. 30H is the ASCII of 0. We are reading 2 and 5. We want to make the number 25 by multiplying 2 by 10 and add 5 to that. So we have to multiply this digit, that digit at the 10th position by 10. So we are moving 10 to BL, then doing mul BL. Now AL equal to AL content into 10. But if we are reading 25, now AL contain 20. Then we have to read the next character h, 01h int to 1h. Now the second character in AL. Okay, there is a chance that register content may change when you invoke an interrupt. So better preserve the previous data, move some CL, AL push CX. Okay, now our value is, our data is preserved. Now let us read the next character, then sub AL comma 30H. Now the digit in AL, and next we want to create the number by doing 20 plus 5 or 20% CL register, and we preserved that. So we have to pop it, pop CX. Now 20 in CL. Okay, we have to add CL comma AL. Now the number 25 is in CL register. Let us do one thing. Let us use two variables, num1 for the first number, for the second number. Okay, now CL contain the number. CL is equal to the 2-digit number. So our procedure is over. So we have to return from the procedure after completing this. Return. After returning, we know CL equal to the 2-digit number. Let us call the procedure. Okay, so after counting for the first number, let us call the procedure read num. After reading, CL will contain the number, 2-digit number. Let us move it to num1 comma CL. After prompting for the second number, call read num, move num2 comma CL. Now num1 and num2 carries two 2-digit numbers, and we are terminating the program. Okay, let us try this. Some add num to ASM. Okay, translate. Then link obj add to num 25 first number, 36 second number. Okay, it works. Let us debug this. Y colon slash awesome slash td add to num.exe. Okay, first message displayed. We are going to call read num. See, you can't see the macro name here. Okay, because the macro expanded. Every macro call will be replaced with the body of the macro. So we are going to call read num. Okay, AH01 INT21H. We are pressing 2. See, AL carries 3 2, ASCII of 2. Then we are subtracting 30H, AL is equal to 2. Then BL 0A mul BL AX equal to 20. We are moving that value to CL. Okay, you can see CL equal to 14. Then we are preserving the data, going for the next digit. Pressing 25. CL equal to 35. Sub AL comma 30. AL equal to the digit 5. We are popping CX, adding CL comma AL. Now CL is equal to 19, that is 25. Then we are returning, and we are moving CL to num1 and displaying the second message and calling the read num procedure for the second number. Okay, h comma 01, we are pressing 3, we want to read 35. Now AL is equal to 33H, ASCII of 3, sub 30, AL is 03 now, then BL equal to 0A mul BL. Now AX equal to 1E, that is 30. Then move CL comma AL, put CX, we are processing 30, going for the next digit, I am pressing 36. Now AL equal to 36, ASCII of 6, then sub AL comma 30H, pop CX, then add CL comma AL. CL is equal to 24. Then we are returning. Okay, then moving CL to number num2, variable num2, then terminating the program. So we read two numbers, one in num1 and num2, the second number. We used a macro to display the prompt and used a procedure to read the number. Now we can do the usual thing, move, take one number, some AL comma num1, first number in AL, move BL comma num2, second number in BL, add AL comma BL, or result in AL register. Okay, let us add 2, 5 and 3, 5. Okay, let us save this. Translate this, bring this, turbo debugger, 2, 5, add CL comma LC, CL equal to 19, that is 16 plus 9, 25. We are at the first number, we are returning, then displaying the second prompt, then calling the procedure read num again for the second number. We are pressing 3, the second digit of the second number, 3, 5, add CL comma AL. Now CL is equal to 2, 3, that is 3 to H, 35, 32 plus 3, 35. Okay, we got the second number, then moving the second number to variable num2, then taking the first number in AL, that is 19, that is 25, and taking the second number in BL, that is 23, 35, add AL comma BL, result in AL, AL will be updated. There is 48 plus 12, 3C. The answer is correct. And we are terminating the program. So what is the difference between macro call and a procedure call? Every macro call will be replaced with the body of the macro. A procedure call will never replace with the body. The control will be transferred to the procedure, and there are two types of procedure, far and near procedure. We have used a near procedure, a procedure which is declared in the same code segment. See, this is the syntax: procedure name, proc, then far or near, then RET, return from the procedure, then NP is an assembler directive which shows the end of the procedure. Here the macro definition, macro name, then macro is the assembler directive, then this is the argument. CMSG is coming here, and here the string declaration. Every string declaration ends with a dollar symbol. Then macro call and procedure call. You can specify the macro name along with the argument. At a procedure call, there is an instruction named call, then procedure name. See, we have declared the procedure after the statements for terminating the program, and it is in the same code segment.